going to talk about isosceles triangles and proofs today. A lot of the information about isosceles triangles you already know, so it's going to be a review, and then we'll kind of build on that and get into our proofs. So when we have an isosceles triangle, remember that that means two sides are congruent. So in this one, they told us that AB was congruent to BC. So if that is true, in this triangle, the vertex angle is angle B. The vertex angle is where those two congruent sides meet. The other two angles are called the base angles, angle A and angle C. And we know from the isosceles triangle theorem, we've been using that one, that in an isosceles triangle, the base angles are congruent. So if I've got these two congruent sides, the angles across from them are congruent to each other. So you always have to be careful where your congruent sides are and identify the angles across from those. The legs are the two congruent sides. So in this triangle, it's segment AB and segment BC, and the base is segment AC. So these are the legs, and this is the base. And those two are the base angles. All right, let's do some work that has to do with this concept. So we take number 1, for example, and notice that here I have an isosceles triangle with two congruent sides. So I know that the angles across from those sides have to be the same. So this must be 35. So to find x, I'm going to do 180 minus 35 plus 35, which I know is 70. So angle x must be 110 degrees. And then if we come down to the bottom triangle here, my 96, notice that's the vertex angle. So if I do 180 minus 96, I should get 84. And I know that these two angles must be congruent. So 84 divided by 2 gives me 42. So y must be 42 degrees. So that's how we do it. Number 3 throws in a circle. Now we haven't studied circles yet, but I think you know a lot about circles. For example, this segment from the center to the outside is a radius, and from this center to the outside is also a radius. And in our circle, well, every radius has to be the same. So all it's done is it created an isosceles triangle for us. So this must be 42, just like the other base angle. So when I subtract those from 180, oh, I get 96. Kind of like the previous question. That was tricky. All right, now number 5, I'm not going to do for you, but I've created a problem very similar to number 5 for us to work out so that you can go back and do number 5 on your own. So we're telling you here that in triangle JKL, angle J is 80, and JK is congruent to JL. So I've got an isosceles triangle, and if this angle up here is 80, then the other two angles must each measure 50. That's going to come in handy. Because right here it says that angle K is 2x plus y, so that's 50. And angle L is 4x minus 3y, and that one's also 50. So there's our system of equations that we're going to use to find x and y. Now when you're solving a system, remember you can use substitution. Elimination is my favorite, so that's what I'm going to do here. I'm going to notice that this is a negative 3y, so if I can make this one right here a positive 3y, then I can cancel and eliminate things. So I'm going to multiply the entire top equation times 3. So that's going to give me 6x plus 3y equals 150. Don't forget when you do this to multiply times everything all the way across. And the bottom equation didn't change at all. 4x minus 3y equals 50. And now our process is we just add those together. 6x plus 4x is 10x. 3y minus 3y cancels. 150 times 50 is 200. Divide both sides by 10, and I think we find out that x is 20. Now all I have to do is go back and plug it in to see what y is. So the first equation says 2 times x plus y is 50. Well, that gives me y equals 10. The next equation says 4 times 20 minus 3y equals 50. So if I subtract that 80 from both sides, I get y equals 10. So it checks out on both of them. X is 20 and y is 10. That's the correct answer to that question. So it just involved an isosceles triangle to set up our equations, and then we used elimination to solve our system and end up with an x and a y that work in both equations. Remember, if it doesn't work in both equations, it is not the correct answer. So be careful with your systems. All right, so there's some more practice like this on the back page, and you just keep plugging away at your isosceles triangles here. And then we get into a couple of proofs. Now, we've been proving triangles congruent by ASA, AAS, SAS, all those other things, and then using CP/CTC. These particular proofs, we're warning you ahead of time, you're dealing with isosceles triangles. You're probably not proving triangles congruent. So just a warning about these practice problems. Let's take a look at number 12 because it looked a little bit complicated. So this one says given CT is congruent to CP, I think have an isosceles triangle there, and then it says that AT is congruent to AP. So I have another isosceles triangle. So I'm going to start with that in my given. Just copy it down. Now let's look at what they want us to prove. They want us to prove that angle CTA, so this little part right here, is congruent to angle CPA, this little part right here. So that seems like kind of an interesting request. I know in the big triangle, if these two sides are equal, then those two angles must be equal. And then I know in the smaller triangle that if these two sides are equal, then these two angles must be equal. So I'm working out a strategy in my head. I think if I take this CTP angle and subtract the little angle, I could get the CTA. So we're going to take a trip down memory lane and we're going to use something called angle addition to work on this proof. So let's start with what we know. If I've got these congruent sides, then I've got congruent angles. So I'm going to name angle T as angle CTP because you can see this angle T is different and we can't just call them both angle T. So I'm going to say, and you could also put numbers there if you wanted to. Angle CTP, this angle right here, is congruent to angle CPT, this angle right here, and that's because of the Isosceles Triangle Theorem. Well, remember, sometimes that was called the base angle theorem. Then I come over to my little triangle. If AT is congruent to AP, then this angle, ATP, is congruent to the smaller angle, APT. Same reason, isosceles triangle. If two sides are congruent, then the angles across from them are congruent. Now we're going to get into angle addition. And I think I'm going to go ahead and number my angles just to make my life easier. I'll call those 1 and 2, and I'll call these 3 and 4. All right, so I'm going to say that the measure of angle 1 equals, so that's angle CTP, this whole thing, equals CTA, measure of angle CTA, plus ATP, which I've now numbered as angle 3. And the same thing on the other side. The measure of angle 2, that's this one CPT, this whole thing, is going to equal CPA plus this APT, which is angle 4. And that's angle addition. When you add two smaller angles together to give you a larger angle, that was angle addition. The little angle plus the little angle equals the big angle. Now, well, what do I know about angle 1 and angle 2? Well, we said right here, angle 1 and angle 2 are the same. Alrighty, so I'm going to go ahead and say that these two are the same. Angle CTA plus angle 3 equals CPA plus the measure of angle 4. I think I'm going to call that substitution, because I substituted this expression for angle 1 in for CTP and this expression for angle 2 in for CPT. Now, what do we know about, I forgot to put a letter there. What do we know about angle 3 and angle 4? And that one's right here. Angle 3 and angle 4 are congruent. So since I'm running out of room, I'm going to skip. I could write this over again and substitute for one of those, but I'm just going to make a jump right here because I'm almost out of room. I'm going to say that angle CTA, I guess we can drop the M, is congruent to, well, they did have M's, equals measure of angle CPA, because I want to copy the given just like they, or the prove, so that I'm proving exactly what they asked me to do. Make that a little neater. And my reason here, I'm going to say subtraction, because angle 3 was congruent to angle 4, so it's like I subtracted the same thing from both sides. And that's down to my final proof. That was a really strange one, especially since we haven't talked about angle addition in a long, long time for that to come up here. So that's why we wanted to do this one with you, so you could see it. As you can see, the next one uses a perpendicular bisector. We've been talking about that. So that's familiar. That's going to pop into your head more quickly than this angle addition question.